Testing. Test 1, 2, 3.
Okay, so this one can be used then. Yeah.
Yep.
Okay.
Testing 1, 2. Mic check 1, 2. 1, 2.
So I'm pretty sure we got another 10 minutes or so until the talk officially starts. Yeah, that sounds right? Okay, perfect. So I will wait until the talk start time to start talking. Testing. Oh, there we go. All right, so I think we're at about the start time of this talk, so I will begin. So I am Denver Gingerich. I am the Director of Compliance at Software Freedom Conservancy, and today I would like to talk about the OpenWrt build system, how we got all the compliance, and how you can too with your build system. And I'll talk about some other very interesting things, I hope, along the way. So first of all, I want to chat a little bit about what brings us to build systems with an example here. So you may have seen this example around the conference. This is the OpenWrt1, which is a router that we designed in collaboration with OpenWrt, which is our member project. And we put a lot of interesting things into it that you might not find in other routers. So this is the device in person here, so you can get a sense of the size of the router. And it has neat features like this USB-C port on the front is actually a serial port. There is also a USB-A port for peripherals like printers or storage or other things like that. And then you can also find the Ethernet ports you might expect on the back, like a 2.5 gigabit port that also supports power over Ethernet, so you can power the device that way. You'll see that the devices here at SCaLE are indeed powered that way. I see one on the floor over there and over there that just have an Ethernet cable, so very cool use of that. You can also power it over USB-C if you prefer. So there are some neat things inside of the router as well. So you can see that there is an M2 slot here at the top left there, so you can add some storage that way. There is also that also doubles as a mini PCIe slot, so maybe you want to upgrade to like Wi-Fi 9 or Wi-Fi 10 in the future, and you could do that by adding a mini PCIe card to that, because we do expect this device to last at least 10 years, if not 20 or 30. The OpenWrt developers are very excited about maintaining the support for this device for a very, very long time. So I'm super happy about that. There is also a microbus connector, so that's a standard similar to what is used on Arduino for the shields that they have. So that gives you some GPIO pins and other things like that. A few other cool things, like it's got a JTAG header already populated, so you can just plug in JTAG if you like debugging the system that way. You can also add a battery onto there as well if you like the clock to keep running when it is not connected to power. So yeah, lots of things in there for people who like to hack on things. So we would certainly encourage people to do as they like with it. Oh, one thing on the previous page, you can also see there's a switch there between the NAND and the NOR. So if some reason you flash something onto there and it's corrupted or doesn't boot properly, then you can switch to the other one. If you break the other one, also no problem. You can boot over the network. So it is an unbrickable device. And yes, that is a challenge. Please do let us know if you think you bricked it, and we will fix it for you. So why is it that we build these embedded build systems? Well, there are a few reasons that this comes up. You may want to, for example, in the case of OpenWrt and Software Freedom Conservancy, you may want to provide something that you know people will be able to hack on, and that also provides some funding for nonprofit organizations like Software Freedom Conservancy and OpenWrt. So $10 of every purchase of the OpenWrt1 goes to the OpenWrt earmarked fund at Software Freedom Conservancy. So a great additional reason to buy an OpenWrt1. And there may also be other reasons. You may want to sell the device as a for-profit company and make some profit off of it. So, as long as you are in compliance with the license, then, we're happy for those uses of OpenWrt as well, or other embedded build systems. And when you sell a device, you also must comply with a number of things. You must comply with different regulations and requirements. And so that is a reason that I wanted to give this talk, to make sure that people are aware of the obligations and requirements that come with selling a device. And part of that is if you work at a company and you are seeing that maybe some of these things are not being done, you can say, hey, we should fix these things. And then on the other side, if you are a person purchasing these devices, like a router or something like that, we would encourage you to check whether your device comes with source code or an offer for source code, and please let us know if it does not or if there's a problem with that source code. So I will be talking a little bit more about that later, but first I wanted to jump into the bit about compliance here. So when you're talking about complying with different rules or regulations, the big question that you have to start out with is what is in this thing that I am trying to get compliance for? And this is often a very complicated question, and hopefully by the end of this you will see that it doesn't have to be complicated. So the first thing that you will often want to know is what package versions are inside the device. So a list of packages and list of all of their versions, that's very helpful. So that would be all of the upstream packages that you are using. Then you would want to definitely indicate which out-of-tree patches that you have. Hopefully this is not a lot of patches, because then that makes reasoning about your device more difficult, because there are a lot of things that you have to figure out yourself when it comes to security vulnerabilities or otherwise. And fortunately, in the case of the OpenWrt1, the OpenWrt community was so excited about it when it was announced in January of 2024 that between then and November 2024, when the device was launched, they upstreamed basically everything that was required in order to have the OpenWrt1 run with a mainline kernel and other components. So I would highly encourage this for anyone else that is making embedded devices, and super happy that the OpenWrt community did this, because it makes it a lot easier to reason about compliance, etc. So there may also be some non-free stuff on the device, and so you would definitely want to know what all of that is. In the case of the OpenWrt1, there's basically nothing, but on a lot of routers, they may have a proprietary interface and other things like that. So you definitely want to know about that and what is on there. The last thing I wanted to just briefly mention, and this is talked about a lot in a lot of different places, is whether there are proprietary programs that are derivative of some copylefted programs. And a lot of companies spend a lot of time and money trying to answer this question, and frankly, this is not the biggest problem that we see in compliance in various devices. And so I don't want to spend much time on it myself, but I just wanted to note that it is a thing that companies tend to worry about, but I'm going to rather spend the time talking about the things that are the bigger problems that we find when we are assessing the compliance of different devices with the GPL and other copyleft licenses. So let's start going through an example here, and of course I will be using the OpenWrt build system here. And so how is it that we create this source code tarball that is the thing that we produce with the device when we ship it? So this is something required by the GPL, that you have the source code available for something when you ship it. It's not like in a month or 3 months or a year. It is when you ship it. You must have the source code ready for the people who may request it. And you must provide an offer for that source code as well. I don't have the box here right now, but there is an offer for source code right on the front of the OpenWrt box that it comes in. So that is one way to comply. And we would encourage people to make that as prominent as possible. So the first thing we do to get this source tarball for complying with the GPL and other copyleft licenses is we download the OpenWrt base tree. So this is the thing called openwrt.git at git.openwrt.org. So you can download that, clone it, and see how we started this whole process here. Now, this is a pretty small tree. Basically, it just controls a bunch of things about how to compile and install other packages. So there's not too much to it. It's fairly straightforward. Now, this was derived from BuildRoot when OpenWrt started in 2004. BuildRoot had been around for 3 years at that time. It started in 2001, and the OpenWrt build system has diverged a bit from BuildRoot since then. There are a lot of OpenWrt specific things in the OpenWrt build system, such as specific packages that are expected to be installed, specific paths that it uses. But yeah, BuildRoot is another excellent build system if you like some extra flexibility. So anyway, we're starting with this base tree here, and then we are running make menu config. And so doing this gives us a .config file that includes all of the list of configurations that we chose in the menus that we get through this configuration tool. So the type of system that we are building for, the packages that we may want included, and all of those things. So once we have that .config file, then we can run make download, and what that does is it downloads all of the upstream tarballs for all of the packages that the .config file indicates that we are using in the router, and then it also creates a feeds folder that includes a bunch of package metadata, and so those two things are now in our directory. The last thing that we need is a bunch of at least 2 how-to files, and these don't have to be called how-to. What I'm talking about here is the thing that GPL version 2 describes as the scripts used to control compilation and installation of the executable. So that is the thing that GPL v2 says you need. That is the license of Linux and BusyBox and many other programs. And I'm going to describe to you what should go in these how-to files so you can ensure that you are complying with that portion of GPL version 2. Now, happily for software developers, this is something that people who like to hack on things would naturally create. If you want someone to do something with a project that you have made, you would like them to be able to install it and run it on their own system. And so you would naturally create how-to files to say how to build it, how to install it onto your device, etc. And so quite fortunately for us here, this natural intent of the developer and the requirements of the license go hand in hand, and so you can make sure that you are being in compliance with the license at the same time as you are ensuring that people can do everything they want with the software on this device under copylefted licenses, which is exactly why the license is there. So what does this give us when we have all of these things? Well, it gives us a minimal set of things that we can reason about. And by that, I mean when you are considering the different regulations and requirements that you might be concerned about, you can quickly answer the questions that may arise. So for example, with the Cyber Resilience Act in the EU, you are going to be concerned with whether your device is subject to any security vulnerabilities. And if you have a list of packages and the list of versions on the device, then you can quickly determine if you need to further investigate and test for vulnerabilities and then patch them on the device. Because the Cyber Resilience Act, the CRA, requires that you patch those quickly. Then on the flip side, there are regulations like like from the FCC, and those may require you to determine if something has changed on the device, whether you perhaps need to recertify the device. So perhaps there was a change in an upstream wireless firmware, and you would need to then potentially recertify the device. Now, the OpenWrt 1 has been FCC certified, so we are very happy that there are no issues with running OpenWrt on any device that is certified by the FCC. So that's another, helpful thing that we get from building a device, is knowing that if a company says, oh no, we can't let you install OpenWrt because the FCC won't let us, that is wrong, because we have shown that there is no problem certifying a device running OpenWrt. So we have this minimal set of things we can reason about for responding to these sorts of questions about regulations, and we get this from this very simple set of things. So the simple base that we have is this openwrt.git tree along with those how-to files, and then we have a simple config file, so that .config file that lists packages and other configuration of the system as a whole, and then essentially the rest is upstream. So thanks to all that work of the OpenWrt developers, there is very little outside of the upstream code that is going into the OpenWrt 1. And so that is pretty helpful and makes it very easy to reason about. We would encourage other people to try to follow that path when you are making a device. This also leads the rest of the development process to be steered towards simplicity, and what I mean by that is that if someone is adding packages or changing configuration or something like that, they are less likely to import a giant vendor tree or something like that, and instead are encouraged to, by the process itself, add a config line or something else like that to ensure that it is done as simply as possible and can continue to be reasoned about easily. So you don't have to do a bunch of analysis of some giant other bunch of code that you haven't inventoried at all in any way. So if for some reason people still want to add a vendor tree, you can at least show them how easy it is to not do that and to instead just edit the configuration. So we would encourage people to do that as well. And in the case of OpenWrt, based on the simple steps that I showed you on the last slide, we are able to easily produce a self-contained source tarball. So this is 1.2 gigabytes, and that includes all of the source code for all of the tool chains that are needed, the cross-compilers, and all of the upstream packages and everything else. And 1.2 gigabytes might seem like a lot, but we routinely get source code candidates from companies that are 10, 15, 20 gigabytes with a lot of, you could say, extraneous things in them. And so we would encourage companies to not do that and keep things simple so that you can reason about what is in your device and the source code that you are providing to people for compliance with the various things, if for no other reason. So this is pretty cool. We have this self-contained tarball. Once you have the tarball, you don't need anything else. You can run it on any distribution because it has all of this stuff. It doesn't need to download anything online. So you may be wondering, if you do work on embedded systems, or maybe you are assessing some source code candidate that you received from a company when you asked them for source code, say for example that you have a TV, or I don't know, these days like a fridge or a washing machine or something, and you look through the manual or the user interface and it says in fine print somewhere like, oh, by the way, you can get source code at this location. And it's like, you're excited, you want to go get that source code, and then you go download it, and then you open up the tarball, and like there's just a list of folders and no instructions or anything. So that would be a problem because there does need to be something that tells you how to build and install the software that is under these copyleft licenses that have these requirements. So I would encourage you to let us know about that, and I'll mention how to do that later on. But anyway, if you are building one of these systems, you may be concerned about these how-to files, and so that's why I'm going to talk a little bit about what these how-to files look like, and for anyone looking at these source code candidates that companies might be giving you, give you a framework for determining if you are getting what you should be getting setting when you get source code for a device that perhaps you want to do something interesting with, like add a feature or otherwise. So let's fix that, and I'm going to do that by showing you a few different examples here from a project called Use the Source. So this is a project Software Freedom Conservancy started a couple years ago, and the goal of the project is for people to be able to use the source code that is provided for their devices to do interesting things with those devices, to add features, to change the behavior in a way that helps you do what you need to do with the devices that you have. And so I would encourage you to check that out. And now, unfortunately, sometimes companies do not provide enough information to do that, which is a violation of the GPL and other copyleft licenses. And so people do sometimes need to express how they were unable to get interesting things done despite the company ostensibly providing source code. In this case, the source code is incomplete in violation of the GPL. And so we do unfortunately have some examples of that, but we want to make sure that companies are aware of what these issues are and that people are able to discuss them. And so we do host those as well. But I'm going to be going through just the first four items on Use the Source today, and these are all in compliance with the copyleft licenses at issue. And so I would just like to kind of show you how it's done, what these how-to files look like. Of course, they don't have to be named how-to, but sometimes they are. And I'm going to go through some abridged versions, but you can feel free to download the complete source code releases for each of these four products and check exactly how they did it, how they put the source code together, how they created these how-to files, etc. So we'll start, of course, with the OpenWrt 1, and I will start by showing you a diff of the ls between this OpenWrt base tree, that openwrt.git repository that I mentioned earlier, and the source tarball that we provide for the OpenWrt 1. So you can see here that we added a .config file, so that is the file produced by make menu config, and then when we ran make download, then these two extra folders called DL and feeds were added. So DL contains tarballs of all the upstream packages, feeds contains metadata about those packages, and then you can see these three how-to files that we added. Now, the first one is not required by the GPL, but is included here to help you out in case you want to configure the Wi-Fi. And the other two are required by the GPL in the sense that the instructions included in them must be included somewhere in the source code release that you provide for works under the GPL. And so I'm just going to briefly go into those. So first, how to set up the build system. So this is an abridged version because OpenWrt, as you might expect, helpfully goes through every distribution people might use and tells you which packages should be installed for each distribution so that you can then compile and install OpenWrt on a router of your choice. So this is pretty helpful here. I've trimmed it so that I'm just showing the Debian example here, but you can trust me that Fedora and others are all included as well in this file here. So it very helpfully shows you how to set it up on basically any system. So that is how to set up your build system. And then this one I actually didn't have to trim at all. It's all here on one screen. So this is how to compile and install the software. And so it provides a link to how to set up the build system, which is the same information in that previous text file in case you didn't read that one. And then it also shows you how to add Lucy to the configuration so that you can have that web interface available with OpenWrt when you get it installed. And once you've done that, you simply run make, optionally with this -j parameter to use more of your CPUs. And then once that make process is done, you have a firmware image that is ready to install onto the OpenWrt 1. And so this is really cool because what that make command does is it goes out and it takes the source code for the tool chain, it compiles that all, so the cross compiler that you're using, once the cross compiler is done being built, then it will build each of the packages that are in the upstream package list, and then it will assemble all of that into a firmware image that you can then install on the OpenWrt one. So this is pretty cool, pretty simple, straightforward, and then it even shows you at the end here how to install it onto the device, as you must do in order to comply with the GPL. And so it says you copy that firmware image onto the device using SCP, since every OpenWrt installation runs an OpenSSH server. Then you run the sys upgrade command and you pass it that firmware image, and then that will upgrade you to that version of OpenWrt that you just built, optionally with some of the changes that you may have made. And then if you want more info, here is a website you can go to. So this is pretty simple, straightforward, what the OpenWrt developers did for the OpenWrt one. I actually didn't tell them what to do. I just said, hey, can we make a source tarball? And they're like, yeah, let's make a source tarball, and we'll put this in it. Great. So this is what we've got, what developers naturally make when they are given the task of doing this, and it is also what is required by the GPL. So I would encourage companies to have their developers do this to be in compliance with the license. So that was the OpenWrt one, the first example of 4. I just wanted to go through 4 just to make sure that people are, know it's not just us. Like, everyone is doing this, or at least sees that they need to do this. And so in here, I would like to talk about Samsung. So this is an example from a Samsung television. And so we received a Samsung television. We got the source code release for it. And these are some of the steps that Samsung gave in order to build and install the software unlicensed under copyleft licenses onto that Samsung TV. So first, it tells you how to build Linux. So you copy this config file into place, then you run make old config, and then make image, and then you will get a uimage file that you can copy into this place that we will use later. Then for BusyBox, we unpack the BusyBox tarball and run make on that. We pass in a cross compilation flag here because that wasn't included in the make file itself. So they've shown us how to do that. And then we have a BusyBox binary. What do we do with that binary? Well, we put it inside of a root file system image. And so Samsung has helpfully provided this rootfs image in the source code candidate or source code release itself. And you don't have to do this necessarily. You'll notice that OpenWrt with the 1 did not do this. It was just built entirely from source, but Samsung chose to include it. The point here is that there are a variety of ways to arrive at compliance, and you don't necessarily have to do it a certain way. The important part is that you are able to compile and install your changes onto the device, and that can be done in a few different ways. So Samsung is showing us a different way to do that here. So first, you unpack that rootfs image that Samsung provided as part of their source release. Then you remove the existing BusyBox. You copy the new BusyBox into place. Some of these steps are a little redundant here, but whatever, that's fine. And then you can remove that original rootfs image, and then you make squashfs to create a new image from that root file system that you've just modified, and then you can remove that root file system because you now have the image that contains it. Okay, great. So we now have a uimage and a rootfs image. What do we do with those? Well, Samsung goes on to explain how you can install these onto the television. And so first of all, you connect a serial cable to the X-Link port of the television, and then you make a folder called update on a USB memory stick and copy these files that we just talked about, such as the rootfs image and the uimage file, into a folder named update on that USB stick, the one you just created. Then we connect that USB stick onto to the USB port of the TV. Then it says here, while the TV is unplugged, you press the shift key and the tilde key at the same time. You hold those down on the serial console, and then you plug in the power to the television, you wait 2 seconds, and then you press the enter key. So, this is maybe a bit more complicated than it has to be, but Samsung tells us how to do it, and that is what is required for compliance. And then once you've done that, you will get a U-boot menu in the serial console that you have connected to the television. Then you press the 0 key on the keyboard and press enter, and that will get you to a prompt. And in that prompt, you can then type BBM USB, and that will show you a list of options you can now do at this step here. And some of those options are how to flash the kernel image and how to flash the rootfs image. And so you would then press 4 in order to flash the kernel image. You tell it which file to flash. You type in /update/u image. It assumes that is the thing on the USB memory stick that you plugged in, and then it will write that kernel image to the television. Similarly, for the rootfs image, you can also flash that in a similar way. Now, this rootfs image does not contain any of the proprietary components that come along with the TV, and that is not required by the GPL version 2. So this will essentially boot you into a BusyBox prompt. So you know Linux and BusyBox are both distributed under GPL version 2, and so this would be in compliance with GPL version 2. And helpfully, a lot of people have taken this and they've said, yeah, well, we would still like to use some stuff on top of that. So you know, they've written their own or otherwise made sure that you can run other programs on top of this. So there is a project called SamiGo that allows you to do this on certain versions of Samsung televisions, and it's pretty neat that we get projects like these out of these source code releases. And indeed, this is exactly how we got OpenWrt, because Linksys was shipping Linux and other copylefted programs on a router. They were sadly not doing it in compliance with the license, and so they were sued, and then we did get source code from Linksys. And so that was great because that was the first commit into OpenWrt. And since then, they've of course expanded to many other routers. And so I'm very happy that we do, through these source code releases, get a lot of those benefits that the GPL essentially enshrines that you are supposed to have when you receive source code for Linux. Or when you receive binaries, you are required to also receive the source code. The company has to give that to you, so you can make meaningful, practical use of the source code to make changes and install them on your device. So anyway, this is what Samsung did, and an example of a project that came out of that called SamiGo. So super happy that we got that. The next one is perhaps the simplest of all of them, and this is an example from ThinkPenguin. So ThinkPenguin makes a number of devices, including routers. Now, ThinkPenguin distributes routers with no non-free software at all, no blobs of any sort. This does also mean that the routers use somewhat older Wi-Fi standards because there are no versions of the newer ones that have no blobs. But this is pretty cool that ThinkPenguin does this, and they've also made it super simple. So they actually include all of the source code with the device itself. So they include media along with the device, and so you can just take that CD or USB stick or whatever it might be, and then you can get the source code straight off of that. So it tells you how to use it here. You extract this tarball, you go into the LibreCMC folder, and then you run make. So no other configuration required. And then that will build the firmware image, similar to the OpenWrt one. And when the build completes, you will see that the image is found in this folder that it tells us here. Now, every version of the ThinkPenguin router comes with a web interface, so it shows you how to use that to do the upgrade, the firmware upgrade. So you go to this IP address in your web browser, then you enter the admin password, and then you navigate to system and then backup or flash firmware, and you upload the firmware image there. It will flash it onto the device and then reboot with that image that you just compiled optionally, with some changes you may have added. So this is pretty neat and pretty simple. Very cool that ThinkPenguin has provided such simple instructions for what can be a very simple operation. So thanks to ThinkPenguin, I will move on now to our last example, which is for AVM. So AVM is the largest router manufacturer in Germany, and they have provided these scripts as part of the source code that they provided. And just a note, we're talking about, I quoted earlier, the scripts used to control compilation and installation of the executable. And so here, scripts, there are certainly some, scripts run by the computer itself, but you can also see here scripts written in English that we are going through in order to complete all of the steps. And notably, the GPL version says you must provide the scripts used to control compilation and installation, not just some scripts, not random scripts, the scripts. And so what that means is that the scripts that the company used in order to compile and install the software are what should be provided for compliance with the GPL. And this makes it pretty clear, to me anyway, that you get all of the things that they did, and so that should be pretty straightforward because they were somehow able to compile and install the software onto the device, so they can simply just provide you that information, and you can too do that. So this is what AVM provides here. They say they've only tested it on this one very specific version of Ubuntu. Sadly, that is compliant with the license. You don't have to make it work on everything, but that is a reasonability standard that I think is fine. I think if people only test on one thing, I don't think we can force them to test on a lot of different things. But that is what they chose to do. You have to install Ubuntu 22.04.4 in order to build and install things onto this AVM router. So it tells you then to execute these commands on the Ubuntu machine. First, you clone this Git repository. Now, this is a little risky here because you don't know if that repository is going to disappear or otherwise become unavailable. And if it did, then AVM would be out of compliance. And so it would be great if you would instead include this repository in the source code release that is being provided. But if you want to risk it, you can. Just note that you will be out of compliance if this goes away for some reason. So AVM has risked this, and I think this repo still exists, so these instructions should still work. So you clone that repository, run a couple commands here, and then you execute make menu config to select the router that you would like to build it for and save that configuration. Then you run make tools, and that will build a bunch of the programs, including some you may modify if you want to reinstall onto the device. So once you have compiled those, then you need to, similar to the Samsung television, you need to unpack an existing firmware image and then to copy over the files that you just made onto the into that root file system and then repack that root file system into an image. So these are using some custom tools from this Freets project, like FWMod right here. And so in this case, they're showing you how to install a modified version of UClibc into that firmware image. And so this is the instruction that AVM has provided. So you unpack it, copy UClibc into the appropriate place, and then you repack the firmware using another flag to FWMod. Once you have that modified firmware image, then you connect the Fritzbox, that is the name of the router, to the Ubuntu PC. And then you do not yet connect the power to that router. Then you use ifconfig to set up an appropriate IP address. And then you call up this flash tool. You start running this tool called push firmware, and that will sit there and wait for the device to boot up. And then you supply the Fritzbox, that is the router, with power, and then that command will detect that the router has been connected. It will flash this new firmware image onto the router, and now it will be running those that modified UClibc or other things that you may have copied into that. So this is another way to comply with the license, similar to how Samsung did it, and you are once again able to build and install your changes onto the device. Now, I mentioned earlier that this is something that companies generally know that they have to do. I think sadly, not a lot of companies. More companies that I like are not actually doing it, and so that is why you may find when you look in your TV or other device and you find an offer for source code and you try to exercise that offer by either downloading it or emailing the company, whatever they tell you you need to do to get that source code, you may not get the complete source code. And that, you haven't done anything wrong, it's just that the company may be out of compliance. And so I would encourage you to let us know, and I'll provide resources for that shortly. So just to summarize here, we have shown how to make a build system and the software that it produces easy to reason about. We've made it easy to build the software from a build system like OpenWRT's build system, and then we've also made it easy to install that software onto the device by including these how-to files, and we provided 4 examples of how different organizations and companies have provided those scripts used to control installation of the executable. So I just wanted to end here by noting a few things. So this OpenWRT1 router here that you have probably seen around the conference, and a big thanks to SCaLE and the tech team in particular for making sure that they were using kind of the coolest hardware out there to run their wireless system, because I think it's great that we can show that these devices really are reliable and suitable for all of these environments, like a whole conference's Wi-Fi. So that's pretty cool. I would encourage you to come to the Software Freedom Conservancy booth, which is right at the front of the expo hall on the left, and check out this router a little bit more if you want to see the inside or otherwise, or the box that has the offer for source code printed on it. We would be happy to chat more about it. We also do have some left, I believe, available for sale, so you can buy them with cash or card if you want, and we can give them to you in person if you would like to do that. Software Freedom Conservancy is a 501c3 nonprofit charity, and if you like the work that we are doing, I would highly encourage you to become a sustainer of Software Freedom Conservancy if you are not already. That QR code right there goes to that sustainer link that I put on the slide. I would also encourage you to check out Use the Source, the link just below that, and you can take a look at the different source code candidates that we've received for different devices there, and whether there were any issues with them, whether it was easy to make changes to the software based on that source code. And it also has a little form that you can use to upload source releases or source candidates that you may have received from companies if you are concerned that they might not be compliant, want to start some discussion on that. I would encourage you to check that out. Now, if you are not sure about a violation, a GPL violation or otherwise, and you would just like to let us know about something, I would encourage you to email us using this address, compliance@sfconservancy.org. I read every email that comes into that address. I may sadly not be able to respond to all of them immediately because we unfortunately get a very large quantity of GPL violation reports. And so please do let us know, though, because even if I don't reply immediately, it does get added to our list of potential open violations so we can prioritize what we work on accordingly. So I would encourage you to do that. As you might expect from a talk by me, the slide source code is also available here. So at the bottom right here, you can click on that link, going to the last page of the talk slides here at the URL at the top, and then download the source code for these slides. So thank you very much, and I would be happy to take some questions about build systems, use the source, any source code you found that you think is awesome or you're concerned is not awesome, and would be happy to chat more about that. I think we have about a little under 20 minutes for questions, so thank you very much. Yeah, hey, I'm just going to walk this mic over to you here. I don't think we have any other.
Thanks. So I wanted to ask you about the relationship between the OpenWRT1 and NICs? Because NICs, I've heard rumors that last year's SCaLE, like NICs was running on the OpenWrt ones here. And then yesterday at Planet NICs, Ron, who led I guess the morning keynote, said something about NICs and OpenWrt1. So, I mean, are those rumors true? Is there something going on?
So, I mean, you could ask the SCaLE tech team for more information. I haven't talked to them about NICs OS in particular. I don't know if anyone wants to comment on that from the tech team here or otherwise. Sorry, you'll have to pass the mic around if that's all right.
So yeah, just this is Rob Hernandez from the tech team. So we don't actually run NICs on the OpenWrt1 yet. We're running OpenWrt, but we do run NICs on the core routers and other servers that are running things like bind and DNS or DHCP and all that. So.
All right, that's good to know. And I think, I mean, I can't comment on any specific distributions we've done this for. You can maybe ask the NICs OS people about this if you're interested in more. But we do generally, if a distribution wants to run on OpenWrt, on the OpenWrt1, we do often send them hardware units so that they can do that. For example, the OpenWrt1 does run Debian, thanks to some work from different organizations on that. And it would not surprise me if you see NICs OS running on the OpenWrt1 in another year or so, or maybe even sooner. But yeah, that I think is the state of things, but I'd be happy to chat more with, whoever is interested.
And then the other thing is in the SCaLE network repo, which is on GitHub under the SoCal Linux Expo org, it's all of our code for running the network. We do have an experimental build of NICs OS on the OpenWrt1. So we tested one on the floor. Yeah, it's just experimental. We just felt like. Yeah, there was one in the lower conference area. So it works. Yeah, we've got a team member working on it actively. Yeah, and we've talked with Denver a couple times about kind of the whole thing. So.
Yeah, for sure. I mean, that's one of the neat things. And actually, the OpenWrt developers were very insistent when we made this hardware. I was maybe even a little bit surprised, but they said, yeah, we don't want it to say OpenWrt anywhere printed on the box itself. So you'll see that, this whole blue router here, there's no OpenWrt. It just says 1 on the box itself. And so really they knew from the start that they didn't want it to be just an OpenWrt thing. They wanted people to know that they could be comfortable and confident in running other operating systems on the OpenWrt1. And so I'm really happy they made that decision. Yeah, we fully support that. I mean, that's the whole point of having hardware that you control, is that you can do what you want with it. You can install whatever OS you want on it. And yeah, I'm really happy that people are installing Debian, and it sounds like NICs OS as well onto the OpenWrt1. Because yeah, that's awesome and exactly the sort of thing we want to encourage and support. And a big reason why we made the OpenWrt1 because we are concerned that router manufacturers are increasingly locking down routers so that you can't flash what you want onto them. This is usually done in violation of the GPL. Sadly, we cannot enforce against every single company that violates the GPL all at once. We are, suing some companies when that comes up. For example, we are suing Vizio, which is a maker of TVs that was purchased by Walmart about a year and a half ago. And so we want to make sure that while we are making hardware that gives you all these rights, we want to make sure that in other hardware you may buy, you have those rights too. And so that's one of the other ways that we help people get those rights. So any other questions?
So one more from me.
Yeah, okay.
Okay, completely unrelated. I'm aware that the Software Freedom Conservancy has taken ownership of the U-Boot project. Is that correct?
So I would maybe characterize it a little differently. U-Boot is a member project of Software Freedom Conservancy now. That happened within the past few months, and so yeah, they generally when a project joins, they would transfer things like domain names and stuff over to us, so we can be the steward of those resources. And of course, they can move those to other organizations later if they choose to do that. But yes, U-Boot is now a Software Freedom Conservancy member project, just like OpenWrt is.
Okay, so does that mean that you are the maintainers of U-Boot now?
So the maintainers remain as they were and have been, and so we do all of the non-coding parts of projects that join Software Freedom Conservancy, like organizing conferences, paying developers, just managing finances for the projects, and holding assets like domain names or other things that the project may have.
Okay, well that's a huge responsibility, because as an embedded developer, like most of the ARM systems out there are booting from using U-Boot. So,
Yeah,
so
absolutely.
we depend entirely on the U-Boot code base.
Yeah, so we're really happy at Software Freedom Conservancy that projects that are, so notable, as you say, want to join Software Freedom Conservancy because I think there are a lot of advantages that we can bring, for example, like with the OpenWrt1, when OpenWrt comes to us and says, we want to build a router, we're there for them, we can make that happen, within less than a year from conception to shipping devices. So yeah, I'm really happy that U-Boot joined us. I think there was a question behind you, maybe? Yeah.
So I was just wondering, I know you're not a lawyer or an attorney, but as far as like, what do you call it, patent trolls go?
Mhm.
Do you guys have any experience with that, or would know any places to look for other support around that?
So are you saying like is this a situation where you're working with a project that is maybe concerned about these things, or you're just wondering in general?
Yeah, because I've heard about it. It seems to be a problem, and like I've heard even with like open source projects, there's potential liability from especially larger corporations with huge patent portfolios.
Yeah, so I mean that is historically certainly been an issue. There were the widely publicized shakedowns that Microsoft did against people making Android devices, and I believe those are not going on anymore. But that's certainly one of these kind of ridiculous situations where companies are effectively being patent trolls, and so yeah, I would I would like to know more about any particular situations to see if there are ways that we could help. Certainly for any Software Freedom Conservancy member project, if this were ever to be a concern for them, we could assist them with that. I mean, we have resources available to do that, and that's partly why a project may want to join Software Freedom Conservancy, is because we can help out with that sort of thing. But yeah, certainly it is something that we can assist with, and that we have the skills and knowledge to deal with. We haven't yet had anyone come to us regarding the OpenWrt1 and say, no, you're using some of my patented stuff. But I mean, the problem with the patent system as it is now is you can never really know. And so we are certainly ready and willing to stand up to any such claims and defend our projects.
Thank you.
Welcome. Any other questions? Yes, one question over here.
I was wondering what's next. WRT1 seems like a very successful project, and hopefully it builds more momentum and stuff like that. But I'm wondering, kind of, is there going to be a 2, or like, I don't know, just kind of what kind of things you guys are thinking about doing next?
Yeah, for sure. Thanks very much for that question. And so, yes, we did. There was some discussion of an OpenWrt 2 on the OpenWrt mailing list about a year ago or so. And there was a lot of excitement for that project. I think there still is. For a variety of reasons, it's difficult for us to build that specific thing that we wanted to build, including, there's a range of suppliers that we rely on for these sorts of projects, and not all of them have come through in the way that we were hoping. We really don't want to ship anything subpar, so we are working to get together the right set of suppliers and the right system so that we can build an OpenWrt 2. It's not certain what the next one will look like. It's possible that it may be a smaller device that is less expensive, but it's still very much in the design phase. And so, it probably wouldn't be a year, maybe 2 years before that comes out. But yeah, we are absolutely looking for new hardware that we can make. And I'd be happy to chat more about that too if you want to. If you want to tell me like your wish list, stop by the Software Freedom Conservancy booth, and I'll be there for the rest of the conference, for the rest of today and until 2 o'clock tomorrow. I'd be happy to chat more about that or right after this talk. I'm super excited to build more hardware. And, the success of the OpenWrt1 has also, caused us to think even more about other sorts of hardware that we can make because, of course, routers are not the only place where there are concerns about companies locking down devices. And so we would like to expand to other places so that people know that there is at least one option that is not going to be locked down, because I think that's increasingly a concern and one we want to resolve for people. Is there a question? Any other questions? All right. I think not. So thanks again, everyone, for being here and for all of the work that you do in various ways in free and open source software. And I would really encourage you, if you're interested, to stop by the Software Freedom Conservancy booth and become a Software Freedom Conservancy sustainer if you like the work that we are doing and would like to support us. So thank you very much. Thank you, SCaLE, for all that you're doing with the OpenWrt1s and for promoting this excellent hardware that we have. Enjoy the rest of SCaLE.
too when it's tangled up. And it just goes, yeah. Yep.
Is that?
Other way. Yeah, yeah, yeah. Yeah.
How does it work? Okay. So just do this.
Yeah.
Just this?
Or you can do it in the back.
Do it in the back. Right? This way. Okay.
And then just flip that to the left.
Hello. Okay, looks good. And I just.
And then you can just put that in your pocket. And then just be careful with that. If you're staying back here, that's fine. But as soon as you get in front of the speakers, it'll start feedbacking.
Oh, I would. Huh, it converted 6 Celsius to Fahrenheit. And you can also have auto self. Like if you run the settings. So you can be like 12 times 12 equals triple dots, maths, as results, and then insert. What was the contract before? Well, I had part of it, yeah. Negative b plus minus b squared minus 4ac for 2a. That's factoring. So like 3a squared plus right let's do like 4 plus 2 and like 2 squared plus 6 like 6 is 12 nah 12 and 2 squared times 2 so 4 squared is 4.
Okay, I think we can probably make a start on it. And today we're going to introduce a little bit on Flutter, and also something about RISC-V, and hopefully you can grab the opportunities around RISC-V and Flutter. So my name is Yiling, and then I'm a software guy. I used to port all the VMs and compilers on different architectures. I'm the founder of Deep Computing, and then I founded a company about RISC-V, and during the COVID, so very risky. So, and because I'm a software guy, so I never do hardware, particularly myself. And this is my first startup doing hardware. And that's Alan Key says, I'm very serious about software. So before, we always think, oh, we are a compiler guy and VM guy, and then we say we're the best software in the world, you know, because sit on the bottom of the stack and very powerful. And then now, and COVID, I sold my software startup, then I start doing hardware and losing all the money on the hardware. So that is Alan Key's indication you're serious, that means you're going to lose money. So, but anyway, and RISC-V, I think most of people probably heard about it. If you've not heard about it, then basically it's a comparison to x86 and ARM. And what's the difference? Because it's open, belongs to anyone who understands it, who can contribute to it. And if anyone interested, go on to the RISC-V.org and join the community and start contribute. And then they have a very customizable architecture, and all different industry can contribute all different profile and basically it's instructions and for their needs besides the foundation one. And because it's community maintained, just like pretty much like Linux, that means that it's going to live forever. It's founded in 2010 and it's been 15 years. So what actually is RISC-V? Actually, it's pretty big dreams, I guess. Is our hope, whoever work on RISC-V is pretty similar to Linux 30 to 40 years ago, saying that. And besides Windows and ULIS, they want to be 1/3 of the market, but actually Linux is more than 1/3 now. So and you can see all the RISC-V members are all famous members. So they somehow work on RISC-V one way or the other, open or closely, and there are a lot of opportunity around it. And generally saying that the whole ecosystem we still underfunded. That means that still needs help, and probably some people will still give a bounty program for part-time to contributions. So do pay attention to it. So for the past 15 years, the ecosystem grew pretty good. So from the tool chain support all the way the hardware up to the application side, and then it's not too bad. And literally we think that every layer we have them all, but is it good enough? Answer is no. And compared to x86 or ARM, we're still probably lagging behind. And on the hardware side, so I make deep computing makes laptop, and now we all tend to focus on RISC-V more. And then we decided to only make motherboard for framework, which is framework is you got a laptop, you can swap all different architectures laptops. So do come to a frameworks booth or RISC-V booth to see how you can swap the board. And then also it's repairable, upgradable. The reason we choose to partner with framework is that because every 6 months we have a new RISC-V SoC much more powerful than before. Then we have main board, different main board, every 6 months. So it's pretty amazing. So the latest one is the last year we launched the 8-core 2 gigahertz with 64 DDR and then 50 TOPS AI. So you can literally run Llama 7B model on it and DeepSeek model on it. So the RISC-V, the vision is all about open source and open. So, and we're trying to achieve, at least for deep computing, we're trying to achieve is the most Linux friendly hardware, ISA. So which means that we had to do a lot of open source, more than Intel, more than ARM. So which including on the server side or any data center side, and even a small board, then we had to have OpenPMC. And then for the bootloader or in the x86 or ARM side, we have EDK tool to compare to it. It's all open source. And then because we still aim one image similar to x86, one image, ISO can install onto all the hardware. That means we have to get ACPI to work. So besides that, then why we aiming at best for Linux? So we basically, we were trying to have all the kernel upstreaming done before the chip comes out. So basically, and once upstream done, that means that you can upgrade your distro, Linux distro, without any hassles. So the most difficult one, especially for desktop or laptop, in this GPU. So we are working on a project we trying to do a low-end GPU, which with the driver, firmware, everything open source. So that means that no one had to suffer that what Linus been saying, the GPU driver always a problem. So, and exactly the same as AI now, because they're very close, just like siblings. So, and back to Flutter. Why is Flutter? Because for stack. And Flutter, it is like a graphic stack, like Linux distro. In traditional desktop, you have KDE, which is based on Qt, your GNOME, based on GTK, and then you have Mesa and Wayland, and all this, and sit on top of the GPU drivers. So Flutter, what it is, actually Flutter is originally from Google, and it's been always a competitor for Android since it's born. So, and the history of Flutter is that it's a JavaScript. Nasbet is one of my good friends, which is back in the old days of the Java VM. So he joined Google 2006 and started working on the JavaScript V8, and he finished it. And then that is your whatever the browser you run in the virtual machine, Java V8. And then he started doing that. So finished another VM, which VM and language is better than JavaScript. But a VM or Java, another new language doesn't solve the business issues. So, and in 2015, the Dark Developer Summit, they introduced Flutter. So basically, it's a graphic stack or application framework that powers you writing an app. So now Flutter is very hot. So because it's cross-platform, so it cross the Android, Linux, and some other platform as well. So basically, it becomes a very close, and iOS as well. So it's cross-platform application framework, so people can pay attention to it. And back in 2023, so when I making my tablet and laptop, one guy called Joe, and he's from Toyota Connect, and Toyota Connect is working on the Automotive stack, the graphic stack. So, and we start paying attention to it, and at that time V8 and that isn't good enough to support RISC-V. So, and wait until 2023, we got Wasm and we got Dark backend to support RISC-V. Yep. Yes, good. So, and Flutter, we have two versions. One is desktop version, the other one is embedded. So, and we call it embedded, and then Toyota working actively, because the reason why Android Auto is very heavy. So basically, if you run the full Android, then you need at minimum probably 4 GB RAM or 8 gig of RAM. Now it's crazy, you know, everybody knows DDR killing people, right? So, and then all the automotive and the infotainment, they want to cut the hardware. So Flutter, you just need, I think on the ARM side, and at that time, Toyota working on it or Suzuki working on it, it just need 1 gig or 2 gig of RAM with embedded Flutter. You can get the whole UI working. So it's pretty impressive in terms of performance and sizes. So, and we pay tribute to Joe and leading this effort and getting the first Flutter release onto AGL. He called it Quirky Quebec. So back in 2025. And he spent a lot of money buying my laptop, tab, until we sponsor them on more on the hardware on it. So this is the AGL's release with the RISC-V support and Meta Flutter, and based on Yato, Yato Linux. So people can get check on it and say hello to Joe and feel free to contribute. And this is state of it. So you can basically, if you're AGL conference or automotive for like embedded world, they will show all the hardware running the whole infotainment or control based on the Flutter, and on the ARM side, on the RISC-V side. So it's pretty amazed, you know, based on the time and effort, and it's pretty good, you know, very compatible, very competitive against Qt or Android. So, and what less actually for RISC-V, we just got the latest chipset based on the latest standard called RISC-V. So there's more thing needs to be done for the whole AGL plus the Flutter side, the stack. We need RISC-V build, and we are alongside with AGL, see how we're going to support with all the hardware and get this over. And more importantly, because Flutter is built on top of 2 VM, so on the server side, basically they based on the JavaScript engine on Android platform. And then if on the Linux side, it's based on the Dart. So, and both VM had to, for the performance-wise, especially for the drawing or memory movement, and this one we need a little bit of optimization work on the vectorized instructions. So, and need improvement, performance improvement. And then more and less now, because people know infotainment is going to have a lot of AI compute on it. And then Flutter just need another AI framework equivalent to on the website, like WebMN, WebNN, or WebGL, all these AI framework for the AI to know their local model onto the compute, and then to do all the AI work. So there's a lot of interesting activity going on if people have interest in, and we're still thinking how do we propose the API and package for the Flutter AI framework for local compute, which sit on top of a vectorized instruction and the future matrix instructions. So, and even MPU. So people probably heard about Tesla with their latest chip coming out, I think it's the A5. They have a lot of AI compute. So how we going to, we're similar to all other automotive MPU, so we need to find out how Flutter can do make use of the MPU on the AI age, especially for all different models. So you have Whisper for language, and then you have simple LLM, or you have a complex LLM, talk to Grok or whatever, those things. So there's a lot of opportunity, especially for the AI age, and I think people can jump onto the project and the trend and learn something new about it instead of the old infotainment functionality, which is pretty boring, I would say that. and pretty fixed function, so easy to do. I think AI side is more interesting. Okay, so this is last page. You have read it on all the RISC-V project on Flutter. And then if you guys interested in learning the AI application for Flutter, then look through it. And then also, and you can try on the AGL release on any of our hardware, even the desktop or tablet, to play around with Flutter. And then once you have all the knowledge, and feel free to contribute all these improvement onto the open source Flutter, and which is actually a Flutter, even though from Google, but actually it's quite much more open than Android. So that's it. That's for today. Any questions?
Yeah, hey, is there a mic up there? Maybe
Yes, sure. Yeah.
I'll run the mic as well. I'll start with the first question.
Good.
So is Flutter, I assume Flutter's providing more of the UI? I mean, is it kind of an operating system? And then, but specifically, the reason I'm asking that is, where do you see RISC-V and or Flutter on the edge? You're talking about automotive, but what about in like kind of edge? Because RISC-V is an inexpensive chip, right? Does it make sense getting as some sort of edge devices as well?
Yeah, I would think that, thank you for the questions, and basically I think if you can do automotive, you can pretty much do all the edge and anything with AI with the tops coming. And then the difference between RISC-V and ARM is that, and RISC-V chipset guy usually listen to the open source community more than ARM.
Yeah.
Because ARM actually, when you make a SoC, they already can ship KK volume. I would say that they already start making money. And when people making money, usually they don't listen, right? Why? Because I already ship 1 million a year. I don't want to touch
Right,
nothing.
don't interrupt the revenue stream.
Yeah, no, exactly. Don't change anything, man. Otherwise, it broke, right? So that's why usually ARM's upstreaming is really slow. It's getting there, but it's still very slow. But in terms of RISC-V, it's still, all the ecosystem is not mature. They listen to people. So what do you want me to support you? And then that's why I did a talk back in the Ballroom C, talk about kernel upstreaming. It's just, we broke the record. We start upstreaming before the chip comes back, right? Mm-hmm. And the code is very compiled. It can't run, but it's already breaking the record because we listen to the community. If you don't upstream and you don't have features, the more you change it on your branch or LTS, the harder you're going back, right? So that is the advantage of RISC-V. We listen to not you guys, right? The reason, probably I'm the only hardware guy doing a lot of talks on the open source community, because I want you guys contribute, and want you guys listen, and want you guys to earn money of it and spend money of it. Right? If you guys spend money on RISC-V, you know the pain. And then if you spend money buying deep computing stuff, I usually listen to you to death. You can beat me to death. And then I will fix whatever you ask me to fix. And if not this generation, with last generation. And then I give you rebate back to make RISC-V better and better, to achieve the vision of this.
Cool. Any other questions? Here, because if you put them in the mic, then they'll get in the live stream.
So I had this misconception that Flutter, because it's Dart, like required JVM, and I just looked it up and it doesn't. It requires a Dart VM, which I didn't know was a thing. So does that mean that there has to be a Dart VM compiled for RISC-V for Flutter apps to run?
Yep, everything is supported.
Okay.
Dark. So back to the table. Dark is supporting RISC-V. It's well earlier than 2023, but it's just not optimized.
Okay.
So basically, now it's already everything's running. You have Dart. You can compile it to WebAssembly, but you still need a WebAssembly VM. So the WebAssembly VM is usually V8 or Node.js. So and it's all VM based, dynamic language based.
So I was reading about the Dart VM. So you mentioned you can target WebAssembly, but normally like on mobile, when you compile Flutter apps, it's ahead of time compiled into native code for, you know, the ARM that.
Yeah, and they have certain thing can ahead of time, certain thing you cannot. So basically, you still need a minimum VM running.
Okay.
So,
For
but
the
that's
things
very
that-
lightweight. And basically now the CPU is fast enough. You don't need to compile, it still runs very fast.
Okay.
But it just, if you optimize it, you usually get much better performance.
Okay, so not everything is ahead of time compiled. A lot of it is still JIT compiled.
Yeah, yeah.
So for these sorts of automotive applications, is there a requirement that these processors have to have some degree of radiation tolerance, or not? Can you kind of speak a little more to that? And then, if so, are there radiation tolerant RISC-Vs being manufactured at this point?
Yeah, yeah. You can go to the RISC-V booth or deep computing booth or framework booth. You can see all the RISC-V is running there. So you literally can touch it and feel it. Okay.
And then one last sort of,
Yep.
do you envision a sort of relative marketplace for RISC-V alongside, say, Longsun, or you think that other architecture?
Well, I would say that just like Linux, you'll be alongside with FreeBSD, alongside with anything that provides human variety. We're saying that we coexist, isn't it? So, and we don't tend to replace anything. It just gives people a lot of options. You know, we've all, especially we targeted where we becomes the best Linux-based architectures. So I leave the freedom to people to do all the implementation on the industry, in the industries. Yes.
Can you hear me?
Yep, sure.
Okay. Can you clarify the state of the NPUs with RISC-V? I've seen RISC-V chips with embedded NPUs in them.
Yes. Yeah.
Are
For
those
example.
all the-
Yeah.
What's the deal with that? If it's not part of the RISC-V architecture.
It basically is designed coprocessor, so they have a separate IP for the NPU. So because RISC-V is still in a growing stage. For example, I'll give you an example here. Why we have an NPU? Because the profile, the matrix profile instruction, the specification not been out yet, not been rectified yet. So people cannot implement it. Once this one implemented, we think the NPU will die out because this is a completely different instruction. It's not inside the spec. So, and just we see NPU might be an interim of thing. And the software stack you still probably do support for a while. Because usually a spec coming out will take 1 or 2 years for the chip to go. The spec comes out, and then the IP comes out, and then the SoC comes out, and then the board comes out. Usually take 3 to 4 years.
So these manufacturers are creating SoCs, RISC-V,
Yeah.
with NPU.
Yeah.
We have no idea what instruction sets they're using.
These are all
relevant?
proprietary and all proprietary instructions.
Okay.
Yeah. So, and you will see, and feel free to come to the RISC-V community booth to take a look, or the video on YouTube, how you know the large language model or Whisper, whatever, all the run on the MPU, on the RISC-V laptops. So, thank you. Thank you.
Okay. Whoa. Wow. Okay. Yeah. Sound check, folks. Testing. All right. Can you guys hear me, but you're not too deafened? Raise your hand if you're deafened. Sorry. Let me move this. Joking? All right. I want to put this in my back pocket, just like the guy said. And I'm going to plug in the HDMI port on this ancient computer of mine, which requires a USB-C adapter. Still a couple minutes early, right? Say again? Oh, it already has the USB-C adapter too?
Yeah.
Wow, you guys are high-tech. High-tech, low-tech.
Right here. And
You guys are great, you know? Give Phil my regards. Or you, if you told Phil to do this. This place is great. I'm going to plug in power because this is a very old computer. My Linuxy computer died yesterday. And I spent about an hour trying to revive it this morning to no go. So I'm using my old Mac. But you know what? Mac is built on BSD, right? So it's got cred. There we go. All right. All right. So they said turn my screen to 1980 by 1024. Is that okay though? Okay. So the next challenge is this webcam working. Shouldn't be a challenge, it works. You know that Steve Jobs, every time I have tangled cables like this, I think of Steve Jobs. They say that Steve Jobs hated tangled cables, which is why he loved Bluetooth and all that kind of stuff. All right. You don't want to see me, you want to see the interesting stuff.
You're the interesting stuff.
All right. Oh man. Have you? So a lot of you have heard of ESP32. That's cool. How about RP2350 or the RP2040? Yeah. How about everyone's heard of Raspberry Pi? Okay. So the Raspberry Pi is very famous for its Raspberry Pi board. But has anyone heard of or used the Raspberry Pi Pico? Yeah. You know, the Pico is nothing like the big brother Raspberry Pi. The Pico is a microcontroller. It's more a competition to the Arduino. And that's what I'm about today. I don't much like the Arduino. It's really too old-fashioned. But I love microcontrollers. So the modern microcontrollers are the ESP32, which has been around for, is it 10 years? You know, I've got some slides on this. Just kind of vamping while I get this stuff set up. I'm glad they have gaffer's tape here too. I brought my own, but. All right, that's the basics of that. Yeah, where's my slides? In reverse order. All right, so this is my very silly picture of me. I'm wearing my Rainbird hat here, and the reason I'm wearing my Rainbird hat is that I work at Rainbird. And I got to say kudos to my boss, who is a real AI enthusiast. He got us started on AI about a year ago. And it's because of him, really, that I've learned how to do agentic programming. So, how many of you guys have heard of Rainbird? They're the ones we do sprinklers, irrigation controllers, okay? And so my day job, is to test the mobile apps that control your sprinkler system that's at your house over the internet. So one of the key things that I want to be able to do, every time I tug this cable, it pulls the thing away from where I've carefully adjusted it. Okay. Sorry, guys. I'm not used to all this sophisticated audiovisual equipment. All right. Stay. All right. Can you still hear me? Okay. Yeah, so I test these irrigation controllers, and they have blinking LEDs on them, right? Well, the state of that blinking LED is pretty important to debugging that device, but it's not logged anywhere. So this little device here, this red, this little device, this red thing, is an RGB color sensor. And yeah, so this RGB color sensor, I got really interested in because I can point this at the LED on my device under test, my sprinkler controller, and have my this ESP32 device here can log the state of the RGB color LED. So that was the whole reason I embarked on this learning how to program these little circuity boards, because I'm not really an electronics guy. I'm more of a software guy. So I got a few thumbs up on people knowing ESP32 and even RP2040 and 2350. Oh, hi. Thanks for coming, guys. Stuff keeps moving off camera. So this, what was I going to say? Oh yeah, I'm more of a software guy. But when there you go, we got everything on screen at once. All right. So have you guys, who programmed here back in the Arduino days? I bet you David did. And you remember the slowest thing about programming these Arduinos and even these modern day ones is the compile, edit, debug cycle, right? You got to wait for the thing to compile and then upload, and then you can see the results of your testing. Or I mean, what you just changed, right? So Seed Studio was an early supplier of hobbyist stuff, which is why I called it Speedy with 3 E's, because Seed Studio had 3 E's. And Seed Studio still makes awesome ESP32 stuff. So I want to be speedy. I want to stop waiting for the progress bar as we make changes in our firmware code. So these are AI generated, obviously. I'm not sure why it said amortizing the flash text. But the traditional way you develop these things is you make a couple lines of change in your code, and then you have to wait for the thing to compile and upload to the board. If you use AI, though, an agentic AI loop in a loop, you can not only have it make the code changes for you, but it'll make them probably correct the first time, as long as it has the correct pinouts, which you can tell it to read the data sheet off the internet. And you can do multiple changes at once, because I'm going to get in the demo part here. It'll be more interesting, and hopefully override those guys in the light blue shirts, which are having a very interesting conversation. So let's get into the demo. I was going to give you guys an opportunity to vote and choose between RP2350 and ESP32, but due to my sad old 2017 era Linux computer dying yesterday and me having to get everything set up on this also sad and slightly younger 2019 era Mac, I only have the ESP32 ready to go. So enough of the slides. Only 5 slides. I hope you guys are happy that there's a lot less slides going on in this demo than you're probably used to seeing. So I'm going to shrink this window because you don't need to be staring at that the whole time. So I'm actually pleasantly surprised that so many people have said they have heard of ESP32. How many people have actually programmed an ESP32 to do something at your bidding? Oh, awesome. Maybe a little over half the room. That's great. So what I'm going to do here is, man, I wish I had a bar stool to sit on. I'm going to show you how the guy with a flashing, here we go. Okay, this is a board I got just literally today in the mail, and dim, medium, bright. Okay, I'm going to tell it to turn that. The ripple is too bright. So I've been using Copilot. Actually, I want to ask first to get a sense for what you guys are thinking around here. How many people have used one of these agentic or AI like pair programming things to help you code? Okay, approximately half the room also. I have found a way to, and it's not rocket science, but have the AI not hallucinate and not just make stuff up. And what you do basically is, it's not too hard, but if it's working on facts, the more facts it has at its disposal, the less mistakes it's going to make. So like I said, it will actually look up data sheets, and so it'll occasionally make mistakes, but I literally, for this board, if you scroll back, I asked it to identify, I said, I just plugged in a new board on the USB port, identify it. And it literally, it did. So I asked it, have we identified the Feather Neo board yet? And it said that it would look into it. And it actually used it identified, see, it already identified, that's the NeoPixel part number, that WS28128, I'm sorry, 12B. And it identified the board by its by what you get when you run LSUSB. So here is the board that we're looking at. And then I looked up the data sheet. And so now that I'm inside, I'm going to say the LED ripple too bright and busy. Turn down the disco action. So like I said, I'm not really an electronics guy. I'm more of a software guy. But it's really, the AI is pretty good at inferring intent. So I'm using Claude Sonnet 4.6 here as the engine, as the AI LLM. It says, do I want to do all this stuff? I'll just say yes and approve all the file operations. Everyone says you should be careful and not just grant it carte blanche access, which is probably good, which is why it's always prompting me here. But I'm okay with it running PIO. Oh yeah, who's heard of Platform IO? Yeah, it's kind of the modern, I think, way of programming these things instead of the old Arduino IDE. And there's another way of programming these things. In fact, when I pulled this particular board out of its envelope and plugged it in, it immediately mounted a USB file system. And what you can do is actually drag and drop Python files onto this thing, and it'll run the CircuitPython. But here's the funny thing. If you're a human programming these things, I think CircuitPython legitimately is probably faster for a human to work in, right? And especially because it gets you past that compile upload cycle, right, that you have with C. You just edit the file. You can actually literally open an editor of the Python file on your USB stick, and you make changes, and the code reflects. Okay, yeah, so it's less busy here. Oh man, sorry. It looks great in person here. It's still too bright. So I'm going to tell it. Can you guys read this, by the way, or is this too small? I told it to, it's still too bright for the camera, make the LED matrix half as bright. I can make the font bigger. You guys in the back?
Did you make the font bigger?
Okay, I will make the font bigger. Gosh, 24 seems really big. Okay, so this is the line I typed. Is it any better, or should I change the color? I'm gonna make it even bigger. Of course, now my window has gotten wider. It's covering the camera. Okay. Cut the brightness in half again. Anyway, it's doing blue, now red. So there's a couple other concepts that I've learned, which is, have you guys heard of skills? That you can teach your AI agent skills or record. So what I'm going to do is I'm going to say record. So next time I fire this up, it will, so skills are basically a way of giving your agent long-term memory. Because there is, you guys have all probably heard of context windows, right? The context window is what gets built up in the current session. And when you first fire up one of these AI agents, it has, the only context it has is, in this case, if a coding agent, is the files in the current directory. And then you make requests of it, you prompt it, and it responds to those, and your prompts become part of the context as well. So if you don't record things in the files in your current directory, then it won't have them in its context for the next time. So yeah, these sorts of files are an important way of getting long-term memory. So here's another view of the this directory. So the readme.md here is what I've, oh, it actually said it wrote it in agents.md. Interesting. Why don't I see that in this current directory? Oh, I'm in the purple directory, that's why. That's where I thought it was going to be, but it made it one level higher, which is fine. So this is where it said, I've told this thing as I've been working on these two boards to just keep notes. So in this agents.md file, it's where it just takes notes about the characteristics of these boards. Yeah, keep the NeoPixel brightness nice and dim. I think is probably one of the notes it just added to itself. When I asked it to. So what I'm going to do then over here, I'm going to actually try to get this RGB color sensor up and running. So how many people have heard of I2C? Did I ask this already? The I2C, yeah, communication interface. I kind of love I2C, and specifically these, oh man, my camera. Okay, there's a cable coming out. You see that little 4-pin cable coming out of the bottom of this circuit board? It goes into this guy, which is the RGB color sensor. And using this I2C specification, especially these little quick cables as they call them, I love these quick cables because you don't have to solder pins, you just plug stuff in. Soldering is kind of a fun thing to do. I need my gaffer's tape. But I don't want to spend time soldering and desoldering things just to do some experiments, right? All right. Well, at least they're both on screen. I'll reposition it later. So what I'm going to do is I'm going to ask it to detect the RGB color sensor and you know, it's kind of one of those things where sure it's fun to look up the data sheet and find out what the I2C address is for this color sensor, but why not have it do it? And usually the first thing it does is it does an I2C scan to find out all the addresses of the I2C devices that it has detected. So it would go quicker if I told it, all right, just look on whatever this is, hex 32. But I guess I'm kind of fascinated by how this thing can kind of discover its environment and, you know, work and, you know, learn and adapt. So what actually, in preparation for this, I actually did get an RGB color sensor working on a different board, which I could pull up and probably should have staged up here so we don't have to wait for this one to actually do it. Here's actually something I do sometimes. If even it gets a little bit too blinding, even for in person, sometimes I'll put a little diffuser in front of it. Wow, now I need more gaffer tape. So basically, as with so much else in the AI world, as I experiment with this stuff, I think to myself, all right, is this going to replace someone? Well, maybe, but you have to know, humans have to kind of know what is possible, right? Before they can ask a computer to do it. So I don't think that humans are going to be replaced by AI because the AI would just sit there bored with no one to instruct it. The other interesting thing about the context is that all these permissions, whenever it asks me to do stuff, yes, and approve, wait for the rest of the session. I wish there was a way I could list out things that can just be permanently approved. And there probably are with different tools and ways of configuring the AI agent. So in this case, what it's doing, so it wrote the I2C port scanner, but now what it's doing is it needs to read the serial port over the USB connection, because that's the only way it can communicate with the board to see, all right, board, how many addresses are there? What I've done with some of these other boards in here that have little built-in LCD displays is I'll have it display all those addresses that it detects on the screen. Because for a human, it's easier to read the LCD screen than it is to read the serial port. But for the AI bot, it's easier for it to read the serial port. I think it recovered. Oh yeah, press the reset button on the board. Oh man. I did not want to have to do that. So yeah, the one drag about these things is the USB port contention. So in this case, we've got the USB port doing two things. It's taking the new firmware onto it, and it's providing the serial port, which actually makes you realize why some of these dev boards have two ports on them, right? One to upload the new firmware and the other one to continuously monitor the serial port instead of having to flick back and forth. Because when I run this, see, it might say something's already taking up the port. Yeah, I cannot open the port. Oh, wait, it's the wrong number, that's why. Yeah, why did it say USB modem 01? Not on, excuse me. Yeah, it's on 14.3301, not 01. What was it thinking? So yeah, that's the other drag about these things is since they're not, for some reason, every other time I shut down my computer and then come in later, the USB port numbers have changed. And I'll have to ask AI if there's a good way to get around that. Yes, the port settled back to 14.3301. Okay, I'm going to hit reset again and see if we see its port scanning. Oops. Huh. Oh. Yeah, so we've gotten into this conundrum here where when I hit reset to trigger the port scan, it disconnects the serial port for a second. So I'm not sure. I'll just ask it. Problem is, when I tap the reset button, I literally just asked it for advice. See what it says. It'll add a boot delay. Okay, that's a good idea. And it'll print repeatedly the scan results every 5 seconds. Perfect. Thank you for being so helpful, AI. That's what I would have suggested too. So I think set option 1. Would you be better for me, Mr. Bot? I literally, one of the things that's kind of satisfying to say to an AI after it tells you there's options or different ways to do it, or can you suggest typing something in, I'll just say, do it for me, or make it so if I want to invoke Picard. And very many times it can do it for me and make it so, which is, yes, I do want to run that command. And that's the funny thing. So we've all heard the term chatbot, right? And these LLMs got famous a couple of years ago as chatbots. So a lot of them still have chatbot thinking in their artificial brains. But running it in this context as an agent that can actually take action, you know, I mean, it knows if you tell it to read the, look up the data sheet, it'll go out to the internet and find it. But sometimes it's just funny the amount of times it sometimes says, it just kind of like gives me the information on screen, and I have to kind of prompt it, take action. Yes, do that. Make it so. Oh, that's interesting. The port number changes after every reset. That's a drag. But it can overcome it. Yeah, this is one of those situations where I wish this one had an LCD screen on it, because it would make it so much easier. Than this serial port. Yes, approve IOReg. So yeah, the other interesting difference between running on these Macs versus these Linux machines is that there's different commands to detect what the USB ports are, or detect stuff like that. But the AI is pretty cool about adapting to whatever environment it's running in. Yeah, so it'll be interesting what it comes up with. Oh, you know what? I should just disconnect this purple board. That is a really good idea. Oh, it wants me to unplug and replug this one too. Well, I can do that. Yeah, so like I was saying, this has been a learning experience for me. And I think my next dev board I'm going to try programming, I'm going to try to get one of those ones with 2 ports, separate firmware upload port and serial monitoring port, because of all this hassle with hold to boot while pressing and releasing reset. All right. Yeah, see, I don't want to manually enter the bootloader mode every time I upload. That's a drag. ready when you've done that, just let me know and I'll trigger the upload. Boot, tap reset, release boot. Well, I'll do it one time because I want to see this work at least once, right? What did it say? Hold boot, tap reset, release boot. So anyway, I want to encourage you guys to try this for yourselves. The trick is that you might need to pay for AI. So, like I said, my company got us started with a subscription to GitHub Copilot, and GitHub Copilot is not to be confused with the crummy Copilot that you get in Office or attached to your Microsoft Word or whatever. GitHub Copilot is actually pretty legit. And what I'm running here is the Copilot command line interface in the terminal. That's what I meant by TUI. I hope it wasn't too cryptic in the title of my talk to say TUI. Did any of you guys pick up the text mode user interface? Yeah, as opposed to the GUI, right? So, what is it now? Again, hold boot, tap reset. Okay. Thought I don't know why suddenly the camera doesn't want to autofocus anymore. There we go. You want me to wire up the AP? Yes, I do. That's exactly what I wanted. How did it know? So it finally found it. It finally found the address of the color sensor. And so have any of you guys used Copilot, Cly, by the way? Or any of these other text mode? Yeah. And if you've been using them for a number of months, they update usually weekly, it seems like. And in the last several weeks, I don't know, I've noticed they accept asynchronous input. So while it's churning away doing something, you can ask it to do stuff. Oh, it wants it again. Boot, reset, boot. Replace the ripple effect with a solid block of color, because now that we're using the RGB color sensor, we don't need it to have animation. I love it when it says The code got too messy. Let me rewrite it. Oh, this again. Yeah.
I found that I do a lot of my agentic coding in Rust.
Uh-huh.
Compiler provides really strong boundaries of what can and can't be done. Like basically the strongest of the three you can get.
Right.
Have you found that your language selection, like I would never try to do Rust before because it's just too complicated for my brain. Like, have you found that any sort of language selection matters for when you're doing these types of projects? Do you not care anymore because you just tell AI to do stuff? Or is there anything like, and specifically with firmware, I would think that there's some gotchas, you know, for timing and everything that you want to have some kind of guarantees on performance.
Well, that's a really good question. Probably, I mean, these little projects I've been doing are pretty simple so far. So I haven't got any cases where the extra type safety I think would benefit. It said it did it, so let's check it out. So it says that whatever I point this color sensor at is going to reflect it on that matrix. So if I point it to itself, it'll be kind of a weird feedback loop. But see, here I'm pointing it to the red LED on the, see that LED right there is red. So when I point it to it, it's red. I point it to something else, it changes. If I point it at, that's mostly white. You know what actually I need to do, and I have done, is hook up one of these NeoPixels and have it cycle through different colors. I'm looking at the orange LED of the power strip. Yeah, and it turned orange. So it's working. Anyway, I'm going to, anyone who wants some NeoPixels, I've got some. And honestly, I'm very humbled and thankful that there are this many people. I thought at this time of day, surely people would rather be at supper instead of watching yet another demo. So who wants to use a NeoPixel, or who actually is going to use them? They're actually kind of fun. I'll give you a double one. And you get one for asking a question. Thank you. I think I've got a couple more over here. They're so small, I accidentally misplaced them. They're like, yeah, so that's a whole 2 cents worth, each one of those. Who here has heard of NeoPixels? Yeah, they're totally awesome. They, you know, with all you give it ground and power, and then one more line for signal, and that you pulse it just the right way and tell it to change colors. So anyway, I think I've kind of reached the end of this demo. It was a success. It's sensing color. So really appreciate you guys' patience. Oh man, even the problem with these bright LEDs is that even the colors look white because they just kind of blow out the CCD of the webcam. Anyway, if anyone wants to come up and look closer, it looks more interesting in person than over this crummy, blurry video camera. So thank you, folks, and come up front and look at it in person. So yeah, you can see how it detects the red, and then yeah, and that's a little NeoPixel in the upper left as well, but it's not color cycling fast enough to actually make much of a difference. But yeah,
That's pretty cool.
and these things, by the way, you can program these things to communicate over Wi-Fi too. That's what I intend to do, and host a little web server so it'll log all the different colors. Yeah. So if you,
Yeah, there it goes.
yeah,
Seeing the different colors.
yeah. Oh, I found a few more NeoPixels. Anyone else? Anyone else that didn't get one can have a NeoPixel.
Why was it talking to you in British English instead of?
I noticed that. Isn't that funny? Yeah, color, COLOUR. I don't know why. I just don't. This is the Anthropic Claude. Are they British? I don't know.
One of the things you can do is track when
You can move that around.
when things like that happen, it means that your agent's about to blow its context.
Things like what happened?
Well, one of the things you can do is you can have the agent address you as somebody.
Oh.
And when it forgets to do that,
Oh.
and it's gone off the rails. It's
Yeah.
also it does these sorts of accent switches. It's
Oh.
also like, it's gone a little off the rails. Kill it if you agent.
Okay. You know, I've heard that. Yeah, and so they say even if it says it's like 250,000 tokens or whatever, that it'll poop out halfway. When it gets about halfway, it's kind of too much. I don't know.
It's non-deterministic. So
Yeah. Okay. Yeah. Yeah.
So in the end, though, where do you get all your code out? Like, how do you, like, you keep giving it instructions and it keeps changing it.
Oh, right.
But then how do you, like,
Sure. That's a great.
at some point you want to take what it generated and kind of like go through it and pare it down, maybe make it more efficient.
Oh, look. Here's the output of the serial port, by the way. And so as we move the thing over here, and it's doing more red now, see how the red is way off? And then the blue, green. Okay, I'm glad we got that part working too. So, but let me show you, David. I mean, I don't know what to say about it other than to say, commit and push. And so it checks it in your Git repo. But, you know, also obviously you can code
And did you tell it
and take.
that you were to write the code in Python, or did you just let it do whatever?
Well, if you're using Platform IO, which I am, that's C++. And like you may have, yes, I do trust the authors of this folder. So here's the source. It's just one big monolithic main.cpp right now. Oh wait, I'm in the purple. Oh yeah, I forgot. Okay. There you go. Sorry, it's still the wrong one, I think. I wanted to code dot. Yes, I trust the authors. Here's the code. So yeah, it's different. So if you used Copilot or RuCode in VS Code, like see how it says over here, you know, here it's helpfully asking for a chat. You'll see the code change in your IDE, right? But when you run from the command line, yeah, you don't see the code, which is kind of, at first it bothered me. But since I'm looking at something and I can, this circuit board, and I can see it light up and do stuff, it no longer bothers me not to see the code, because what it's doing, the circuit board is doing is,
You're getting visual feedback.
yeah, right, yeah. But sometimes the code itself is the product or is the output. So then the IDE methodology is usually more helpful. So, oh yeah, game night, yeah. That was my pitch for people when I was telling them. I was saying, hey, here's a way to kill time until game night. Although I'm kind of wanting to have eat night right now.
I want to go hit the road because I've got to get back to Washington.
Did you drive down?
Huh?
Did you drive or fly?
Yeah, I drove.
Oh, wow, okay.
Yeah, I had to clean out the rest of the stuff from my, I'm going to take that off.
Oh.
I had to clean up.
Thank you, everyone.
thin out the rest of the stuff from my apartment.